All right, welcome back, everyone, and we're doing no springs today. No springs. We're done. We're moving on to the next phase, and this is the final phase of the big milestone that I've been working on for like about a year now. The final phase is really trying to build the IK system, and the past year we've been doing a lot, and now it's time to start getting these characters animated. I really want to animate characters. So what we need, what I would focused on in this video is to do animation retargeting, and you'd be surprised how little information exists out there. After I created all the code, I was shown a link to Unreal Engine. Apparently, they have some documentation how they do targeting, and after I read it, I'm like, well, I kind of already built that. So I was like, great. This would have been helpful in the beginning and not after I'm done. But yeah, so we're going to do animation retargeting. I'm going to walk you through some of the math and some of the steps that I get it. And probably not, I would probably want to say maybe it's the best way or it's the right way. I don't know. It's just how I got it working. But it works pretty well. I got some cool animations running. I got 3 good animations running, and I'm just shocked it actually works. So, let's get started, because this is going to be a long video, so I'm really sorry. And I found out today that a 7th grade class saw one of my videos recently, and if you are in the 7th grade class or a class in general, I am sorry if I'm boring, or whatever. So just go watch something about Fortnite or something. Turn off this video. Go do something else. But if you're here to program, all right, let's do this. Let's do this. All right. So the first step is we need animation. We need animation data. So to get animation data, I use Mixamo. It's pretty easy. Just go to Mixamo, download some kind of a thing, and you're good to go. There's some issues with Mixamo, but not. I want to say issues with Mixamo. It's just issues with Blender in general and the GLTF format and the GTLF plugin exporter for Blender. So it took me a while to get it working just right. So here's Blender, the new Blender. So I'm going to show you the quick steps of how I get the animations kind of ready to export for the web, so I can actually do things with it. So so first thing, Mixamo gives you a couple of formats, but FBX seems to work the best. So I'm going to import an FBX. I have my Mixamo folder, and let's say I just want to do a jumping animation. So one of the couple things to take note of is if you only need the animations, you probably can don't import the normals and other things like that in Armature. And one thing with a lot of with FBX things, sometimes with Mixamo and sometimes not, that the bones don't connect. They're just like randomly all over the place. So if you need to have the armature bones actually look like armature bones, automatic bone orientation actually fixes the problem for you. Really does a pretty decent job of fixing the skeleton bones. The other two just makes things worse. So just keep in mind you want the automatic bone orientation on. I usually import first, and if the bones look like crap, I import it again. So, but I think some of these right now, the one I'm going to do, doesn't need it. So just keep that in mind. If the bones don't look right, import it again, turning on that feature. So import. And there we go. We got a nice skeleton. It's in a nice T pose. It's great. Beautiful. One thing to note, especially for Mixamo, is that even though it knows the right orientation, it still gets rotated on the X by 90 degrees, and it gets scaled really low. So this is not actually the real scaling. This is so usually when I bring in the model, I kind of just apply everything and just leave it at that. But when you're dealing with animations, you can't do that. You have to leave the transform alone, because the animations are based on the real transforms. So the idea is the animation runs, and then this transform kind of just puts everything into place. So I don't know where this comes from. I don't know why everything isn't just in units, but that's just how it is. So because of this, I had to compensate for this for animation retargeting. So I'm kind of happy that this is an issue, because it just makes things it gave me a roadblock that I had to work through. So that's one thing we're going to have to deal with in animation retargeting. Now, one problem with exporting, once you start running the animation, you can't export it correctly, because in GTLF, I don't use the bind pose that they have it, like the official bind pose, because it exists in the world space inverted matrix. And yeah, it's actually the final product of what you use to actually push to the GPU, which makes perfect sense if you have a system that uses matrices to do skinning, and you have everything kind of prepared for you, and all you have to do is just use it in the GPU or use it in the CPU in your code. You're good and good. But my animation system uses dual quaternions, so all that is garbage. So I can't just grab the bind pose. I have to go through to the nodes to actually get the local space transforms, and then I can then save them as local space transforms, and then compile them into my model space dual quaternions and scale. So the thing is, when you have these animations and you want to do an export, it always exports the nodes in the first frame of the animation. So no matter how many times you can go into pose mode, go to pose and clear all and bring it back to this point, you can't. When I go back to export GTLF, it actually goes back to the first frame, and that ruins my chance to get the T pose or the actual bind pose of the skeleton, until I realize a counterintuitive feature in the exporter. So if I go to export and say GTLF, especially I usually like to have the bin file and GLTL file, because sometimes I like to do certain things with that. I go to meshes, like since it's animations, you can just turn all this stuff off. You don't need any of this stuff, especially if you just want animations. And that's another problem, is that sometimes I can't export animations alone. I have to export them with vertices. So check it to make the binary file a little bit smaller. Now, just leave animations turned on, leave skinning turned on, and limit to playback range. Leave all that. Everything else should be turned off, except for use current frame. This feature, use current frame, I think the name of this feature is wrong, or there's a bug in the system, because use current frame, ideally, I would think it uses whatever current frame of the animation. But what it does, it actually just uses what's currently the current pose at this moment. Because the moment I export, let's say use current frame, and I just want to export it. God, is it? Oh, it doesn't work here. Well, usually in a lot of animations that this automatically goes back to the first frame after I'm done exporting. But if I actually go to the GTL file, the T-pose is saved. So if you have an issue exporting animation, use that feature. Just make sure you have all your transforms cleared out, and then use that feature in Blender. So I probably spent way too much time on this. These are my old files. So these are the files I had from a year ago when I was using Unity. On my other computer, I've been using new files I downloaded, and they work differently. So I'm kind of surprised that these work differently. All right, so no Blender. So keep in mind, it's kind of hard sometimes to get the animations out. But once you get the animations out, we get good to go. All right, so let me open up the first page. So I'm probably just going to give you the primer of what you have to do. The first step is that you need your armature system, or your source armature, or your source bones. Good. I wish I had this in a dark mode. Hopefully you can tell, but you can see this kind of like this green skeleton, and because of the scaling, it doesn't use the regular skeleton. So it just looks like green lines. But that's our source animation. That's the animation I exported from Mixamo and put them into GLTF. So and then I have Vegeta as my target armature. Right now it's in the perfect T-pose, but it actually normally is not in a perfect T-pose. So if I turn off this feature. Do a refresh. You can see the feet are spread out a little bit. The arms aren't. It's hard to tell because you can't see the bones very well, but the bones aren't perfectly straight. But the source is perfectly straight. The source is actually the perfect T-pose. That's what we need for animation retargeting. So it would make sense that the source skeleton is perfect. It's because ideally you're going to retarget it into your Unity project. So what we need to do is we have to basically take our target. If our target has a perfect T-pose, that's great. If it does not have a perfect T-pose, then you can just use some of the code I have in previous couple of videos ago where I show you how to mathematically get things aligned into a perfect T-pose, and it works. So I run that function on my rig, and the legs and the arms are now perfectly aligned. So that's step one. We need both armatures to be in a nice perfect T-pose. And what I mean perfect T-pose, they just need to be oriented on some axis. So it's just easier to orient them all in like a main axis. So like the arms exist on the x-axis and the legs exist on the y-axis. Because the next step is that the way we do retargeting is that we're going to animate our transform, or our source. We're going to calculate all the world space or model space transform. So this way we know the world space rotation for every bone. Then we're going to have a special quaternion that we're going to generate for every single bone that translates it from the world space of our source to the world space transform in our target. And then once we have it in our target world space, and then we do one more rotation, which would do the parent of the bone inverted to actually bring it back into local space of that bone. And the trick I did here is that, let's say I want to take the thigh bone right here, right? I'm going to so when I want to calculate the world space of this bone, I'm going to go get the bind world space of the parent, which would be the hip. So it's the bind pose, not the animated pose, the bind pose of the parent. So with the parent bind pose, I add the local space of our animated, because we're going to have two poses. We're going to have the bind pose and the animated pose. So the animated pose, I'm going to just take that one bone, but add it to the parent from the bind pose. It's just going to be just a quaternion. That's it. And by the way, all the transforms are done in quaternions because I've seen some code like from 3GS and from Unity. They're all matrices and they're not commented and they make no sense. So if you're coming here wanting to do quaternions, great. If you want to do matrices, I'm sorry. I'm not a matrices guy. I've been doing most of this work all in quaternions. So everything is going to be done in quaternion rotation. I totally lost track of what I was saying to put that little disclaimer in there. So yeah, we're trying to get the thigh. I totally lost train of thought. I totally forgot what I was saying. I'm sorry. So yeah. Oh, that's right. The parent. So the idea is that I take the bind pose of the parent, add it to the local space of the animated pose to it. So this way now I get the animated rotation existing in the bind pose armature. The idea is like let's say if we have this entire armature, what I want to do is just rotate just the thigh bone. That's it. Even though I have the automation running, all I want is the entire bind pose just with that thigh bone animated. So basically, I'm isolating it. I'm isolating it into the bind pose. So this way, in an entire world of the entire world transform of for the armature, it's similar to Vegeta because that's the thing. We're transforming it. Even though this is not a one-to-one retargeting because probably hard to tell, but Vegeta's thigh bone, its forward direction points at positive Z. This one you can't tell. Its forward direction is in the negative Z. So actually, even though the Vegeta got retargeted to be in a T pose. Now everything is pointing down on the Y axis, on the negative Y direction. The twist of the bones are completely different. So we have to make sure we transform them correctly. Because if you try to do a one-for-one transform, Vegeta looks like a monster. Like someone's like using psychic powers to to crush his bones. It's not pretty. It doesn't transform. You're transforming it into a monstrous animation. So the idea is that we need to kind of move it from to this world space into this world space. Actually, this local space into world space, into that world space, and then back down to local space. And the special transformation is actually quite easy. Apparently, so if I take the world space of the animated pose, if I take the world space of the bind pose, invert it, and then multiply it by the world space of the target bone, I get the difference between the source to the target. So it becomes like so the idea is, so let's say we take the thigh bone. It has its own, even though it's pointing in the same direction, it has a different twist. So if I get the inverse of rotation of that thigh bone multiplied by this thigh bone, Vegeta's thigh bone, I get the difference. So it's kind of like 5 minus 6. I get a 1. It's the difference of 1. So when this bone is in this state and I multiply it by that difference, it gives me that bone. So if this bone has been rotated and moved around, and then I multiply it by that transform, it then translates it into the same type of motion, but on this bone, because it has that twist, has that specific, all the little bits and differences translated. Because not all the bones are aligned. Like the spine and the head and the feet, they're not aligned. So, but they still work. So the transform does work on other bones, so they don't have to be perfectly aligned. But with having the arms and the legs perfectly aligned to an axis, especially if you have them both match at least the exact same pose, because the arms and the legs are like the most important. Even if they're off by like the spine image, even if they're off by a tiny amount, you probably can't tell. But if you're off by the arms and the legs, you'll notice that the animation doesn't look right. So as long as the arms and the legs aren't about the same pose, it really makes the animation retargeting works. So to recap, first step, make them both T poses. Step 2, make a calculation between one bind pose to the other. Do the inverse of the bind pose of the source multiplied by the bind pose of the target. So once you have that transformation difference, and then all you have to do is isolate each bone transform into the bind pose. So like I said, you take the animated pose of just that one bone, and you kind of apply it to the hierarchy of the bind pose. So you isolate it. So it's instead of just dealing with the world space of the animation, you're just putting that rotation into the world space of the bind pose. Once you have that, you can just transform it into your target world space, and then once you're in your target world space, you just do regular parent inverse of that bone of the bind pose. Granted, this is the parent bind pose. Rotation of inverse to bring it back to local space, and that's the whole retargeting system. I know it sounds difficult, like sometimes, like I don't know, it seems difficult, but surprisingly, after when it's all said and done, it actually works. The code, and once you clean up the code, it's actually surprisingly very little code. It really is. Once you get all this everything kind of set up just right, and you know what you're doing, it's pretty cool. It's pretty easy. I have the original file, so I probably want to show you maybe the original target. This is one I finally got working. It works beautifully. Excuse my variable names, so sometimes when I'm prototyping, my variable names aren't, especially since I'm constantly changing and I'm just keep adding more and more variables, it becomes difficult. So if I see something like this, that means that's like my A local space bone, and this is my A pose world space bone, but it's my let me see, which one is this? It's my bind target. Now I totally forgot why. Whatever. Like BP, that means my B pose, but the parent of the world space of the bone target. Yeah, I think that's target. Yeah, I think it's just target. The idea is like I'm getting all this information. So I'm getting like the local space of the bind pose, the world space of this one, the parent world space of this one, world space of this one, and the parent world space of this one. And then this creates the convert one. Like I said, I take the world space bind pose of A, and then the world space bind pose of this, and just that creates a convert. Then I take the bind pose of the parent. That's why AP is there, and then multiply by the actual animated. So anything with a T, that's the bind pose. Anything with just B, that's the animated pose. And then this caused another problem for me. When you're doing there can be I forget what the word is called. It's like there's like errors in the animation where even though the axes and like when you do quaternions, you can when the axis of rotation and the angle is inverted, it can actually create the same animation. But the thing is, when you put that into like scanning and stuff, it can actually create these bad things. Like this is probably, if you're watching this series, I've mentioned this several times, but sometimes like when you see the animation act up really bad, negate everything, basically multiply everything by -1, and if the animation now works really good or the rotation works really good, that means I get singularity. So it's a singularity, and the singularity is the fact that, let's say the animation axis, the rotation axis is pointing left, and what you need to do is it should be pointing right. So if you multiply everything by -1, you negate it and you just flip it into the other direction. And sometimes you can check for it just by using a dot notation. So this difference, I do a dot notation to the original bone bind pose, and if it's less than 0, then I need to negate it before I multiply it. Else, if it's greater than or equal to 0, I can just do the conversion automatically. So if the conversion doesn't work if diff is in the opposite direction of the original bind pose, world space bone. And then you move it to local space, and that's this piece right here that I highlighted. That is really all the magic of transform feedback. Not transform feedback. That's actually all the magic of animation retargeting. That does all the work for you. It does it beautifully, surprisingly. Because like this part is the important piece, and then isolating the bone, and then just making sure there's no singularity errors, and you're good to go. You're done. And it took me a week to figure this out. I've rewritten this so many times, the math over and over and over and over again, until I finally got it right. And you get to learn it on the first shot. Gotta love YouTube videos for teaching you. So for anyone who thinks I'm a wizard that has infinite knowledge, this took me over, I think, literally over a week. And if you're watching me on Twitter, you got to see the entire process to the very point where I finally figured out where some of my problems were, and I felt like the biggest idiot in the world. Because I'll show you the one problem I had. It was like the last bug, and that last bug, I just kept writing the mathematics over and over again until I got to this really optimized version of it. It's like I got so close to it. And realizing that there was actually nothing wrong with the math that I probably no problem. For some of them, it's just I didn't set up certain things right beforehand, and that's what caused the errors. But all that failures got me into a really good version of like a slimmed down version of the code, because the mathematics was kind of bigger, and I just kept doing things, and I don't know. It's like I said, I just kept doing things until I got really close. Like certain things, the arms would work, then the legs would break. Sometimes I would write code that the legs would work, but then the arms would break. It was just driving me nuts. Just to get something that works correctly for every bone. But once everything was working, then the arms were off. I'm like, man, it's like the legs are perfect, but the arms are almost there. And I'll show you the final problem of how to fix that problem. But yeah, that's the magic of it. So in the test file is where you're going to see the nice cleaned up code. Nice and clean. I have lots of comments in here. I have like information on how to save it, FBX, some requirements, like basically everything I blabbled on all throughout the beginning of the video. And I think I repeat myself a lot in the comments. One thing is like you have to map your bones. So this is kind of like the mapper. So I say. So I make like a simple array. It's every two counts as a thing. It's like bone of the source and then the bone of the target, and they all have the exact same names because both use a Mixamo. Or they both were used. Both. Apparently, Vegeta was rigged by Mixamo, and the animation was created by Mixamo. So, but somehow the bone orientations are completely off. I don't know how that happened, but the bones are completely off. So yeah, and I have I've created an object called animation retargeting. Like in the original one, all it was, I just called it retarget bone, and I literally retargeted one bone at a time. That's how I originally prototyped it. And this was another one. This is my other 3D model of a female. So I make sure that both models are working and everything else. And this is the Vegeta one. So prototyping is a bitch. But all that got replaced by a simple mapper. So I made a mapper, an object that loads in the maps, and it makes things super easier and easier to use. So this is like the nice cleaned up version of it. And I built a new animator on top of that. Rebuilt my human rig. The human rig is simpler than the last version from like months ago. Everything got like I just rewrote everything because I'm using a lot of new data and everything else, and I want to slim down. And every couple of months, I feel like I can do a better job. Loading in GTL and my custom format, I rewrote the objects because the way I was doing it was too complicated. Like not too complicated, it was just too convoluted. The new format, I just like it that I have just these functions. So if I want the debug version of the mesh, it has the predefined settings for it. If I want to just to preview, I don't want to load the mesh itself, just the preview of the skeletons, I have that. If I just want this or that. So instead of having one function with a bunch of configuration options, I just create a function for every set of configurations because all the configurations in the world doesn't really matter if I just only need like 2 or 3 different types of configurations. So that's why I built these two over again for loading meshes because those are the only 4 things I ever need. So then I have a new object called animation machine, and this is really just where all the actual animation is because when I load in the animation information from GLTF, I then need something to animate it. And the animation is, I wrote a new function for parsing out the animation. I got this one that says to do, delete. This is the old one. And then I got the new one. And I actually don't need that anymore. This is actually slightly... I have a newer version of this, which I probably take a lot of that out. And the gist of the new version is that I actually save all the animation in raw, flat floats. I don't do the animations... I don't actually try to create... Like, let's say if I'm animating a bunch of Quatorians, I have to go through and then make an array of Quatorians. I don't do that anymore. I pull out the information out of the binary file as because all it is just a flat array of floats, and I keep it like that. So I don't do an extra bit of conversion. I don't waste memory. I keep everything nice and flat and smooth. and simple. And then I built the animator to accept data like that. And the way I do it is that I just pass in like the buffer and give it like an index into it, and I just just do the quaternion mathematics that way. Because I know, even though it's a flat array, I know every 4 floats is a quaternion. So if I need the first float, the first quaternion, I know like the index of 1, I just say index times 4. So if it's 0 times 4, that means I start at 0 and I go 0, 1, 2, 3, 4, just like how I do it here. If I need the second quaternion, I just say 1 times 4. So it's going to start at 4, and the next one's going to be 5, 6, 7. And I do the same thing for position, for vertex. So the animation data that I'm using basically stays in its pretty much in its binary form, and I just write these extra, because even like there's no point in converting everything into quaternions and vector objects just so I can use this one function. So it's just better off just keeping everything as flat binary arrays and just build the functions I need to use that form. Like I said, the only thing I ever need to do with quaternions is to lerp 2 of them. So I just make a lerp function that pulls the data out of the flat float array, and just do the calculation. Because you kind of have to do this anyway in the original function anyway. So what's the difference between pulling out of 2 quaternions as opposed to pulling them out of an array and using 2 array indexes? So that's the new animator. Like I said, it's more slim, so it's less loading and less wasting memory, because JavaScript is notorious for wasting memory. So instead of having a bunch of mini arrays of a bunch of quaternions, because some frames can be like some animations are like 300 frames, so I have like 300 quaternions. Now instead of having 300 quaternions, I have one float 32 array that's just filled with a bunch of numbers. And also found a new lerp function with the quaternion. I can't remember where I found it from. I'm sorry if you're the one who wrote it. I rewrote it. It's a little different than how I have it here. But when I was animating, when I was lerping between animations, certain things were acting up. So I was just doing a regular nlerp, just lerp and then you normalize it, and that was causing issues. And like a certain point of the animation, like the leg would twitch. It would kind of just twitch, and I just couldn't figure it. So instead of using a lerp, I put slurp, and slurp animation was perfect. So I think I was looking around for like things, and I found something like someone called it a quaternion blend, and it's really just a lerp, but it has a dot product check for it. So remember, like I said, that there's that singularity. That's what this thing that's what this thing does. It kind of does that little singularity check a little bit. So it kind of just does a dot product between these 2 different quaternions, and if it's less than 0, all I need to do is to negate the second one. So s equals 1, and if the dot product is that, then a -1. So during the actual lerping, the second quaternion I negate in real time. So instead of negating it and then applying it to the equation, the negating actually happens in the actual lerping function, the actual lerping equation. So like I said, I just streamlined the process. So this way I don't need to use slurp for oh my god, what time is it? It's like midnight or something. And I was on a meeting call like an hour ago. So yeah, the not interlacing. Oh my god, interpolation. So just slurp interpolation. So this improves the interpolation. So I don't need to use slurp for interpolation. I can still use lerp. Just with this little singularity check, actually fixes the problem. So yeah, I think in the quaternion library, I have quaternion lerp, but now I have a new function called blend. Let's see, in case you guys are curious how to see how I wrote it, that because like I said, this one. find what's it called? Blend. Oh, I haven't put it. This is. I have another version of the Quantorian library. But yeah, this is the original blend function. As you can see, it's very different from the way I wrote it, because it has that check, and then it just does the. It kind of just negates it into a temp. Yeah, it negates it into a temp, and then applies the temp to, whatever. So that's why I kind of changed it. So this way, I kind of, it's like, instead of, I can just do it in real time. Just have that if statement, just change S to 1 and just do a multiplication. Just instead of changing the sign and saving extra variables, I just one variable change and just add a multiplication. So I don't know if this is more efficient, adding 4 multiplications as opposed to doing 4 memory allocations. I'm assuming memory allocations should be faster than a multiplication. But I don't know. I'm not a systems engineer, so I'm not exactly sure about all the. I just know enough to know that division and square roots are bad for GPUs because they're slower. That's basically I can say. But yeah, and then you normalize it. So that's a great thing here. And that's the animation. We have the chain. We have the human rig. Everything's just, there's not really much to it. I don't really would focus too much on it. And then we have the animation retargeting object. Both are rigs. So this way, I just said both armatures with a rig. So this way, it's kind of easier because they have like certain things, and I kind of changed how everything works because now the rigs come with 2 pose objects. And before, when I was doing a lot of this armature stuff, I was doing a lot of things connected to the actual armature bones and entities, and it's really a pain in the ass to use. But it needs to be entities. Every bone needs to be entities if I want to do components and stuff and physics and whatever. So for animation and IK, I decided to change the pose object to hold extra information. So the poses object is kind of like a quick copy or a clone of all the entities, but in a nice flat array. Again, I like flat arrays. I don't know why, but it's not. It's an array of structs. So instead of me going back to an entity to find the bind pose and everything else, I decided to say, well, I'm going to save one bind pose. I'm going to save the bind pose as a pose into the rig, so that's my T pose, and then I'm going to have my animation pose. And so this way, when I need to go back and forth, the rig actually has all the information. So this way, I have rig of the source and the rig of the target, and that allows me to then have my bind pose because I need the bind pose information, and the pose A is my source. That's my animation, and then my final animation for the target is also going to be saved in the animation pose, or just the actual pose, and then the pose can then be applied right back into the entity. So the pose object keeps a reference to the armature, and then when it's all said and done, you say apply, and it just copies all the local space transforms right back into it. And the pose is a little smart. Because every time, if I use one of the functions like set bone, I actually save state, like change state. So if I only change rotation, it's only going to update the rotation. It's not going to update the position. So if I have like a 50 bones, I don't need to do like position and scale for pretty much all the bones. Only the hip bone ever has the position change. So I'm just trying to make things go a little faster. So if it's only equal to that state, then that's it. And I use like little bits for state controls. That's why I'm using the bitwise operator, bitwise OR operator to kind of add the state. A lot of binary. So human rigs, T-pose, and I have a function that generates a T-pose, whatever. It's all the stuff from the previous video, but just neatly packaged in a nice little function. So they have like some configurations, just hip. Like, do I want to okay, this saves the hip, or like what the hip name is or something. I forget. But the hip Y only, that means I'm only going to retarget the Y of the hip as opposed to the XYZ of the hip. So if I want to do a walk animation, but I don't want him to walk away, I can just snap it to just the Y, just to retarget the Y position, so it's only up and down and not left and right and forward. So I got to set the hip. Can't remember why I have to set the hip, but setting the hip is always kind of important. Because that one, well, I guess mainly because it's because I pre-calculate a couple of things. That's why. Because since the hips is the only thing that really changed the position, I need to pre-calculate some scales. So like, you know how I said there's that convert object that translates from one to the other. This does the same thing, but it's a lot simpler. I have some pseudocode at the bottom to make things easier. I have a load map that's just that big array, and auto map. I was kind of hoping to do that at some point, since a lot of mix and mill bones are the same. They have the same name. I could just auto trigger without actually having a map. So when I auto map, I need to get the index from and index to, because they're two different arrays of bones. And so I'm going to link them together. And this is my map object. In my map object, I'm going to like pre-calculate everything. Like I'm going to pre-calculate the converting quaternion, the rotation that goes from one bone to the other. I'm going to pre-calculate that. I'm going to pre-calculate, I think, the inverse of the parents. So this way I don't have to recalculate them during so this way it's kind of trying to get rid of a lot of math operations from the original function, and just pre-calculate them all here. So when I do a map item for every bone, I pre-calculate all the pieces I need, and I have lots of comments that explains it. But it's like it's the stuff I explained before, and then just save it. So that's my mapping information. So I have the index from the from index, the to index. I have the dot check which bone to use. This one says I just save a reference to the bone, so this one I have to go looking for the bone. So it's which quaternion do I use for that dot check? The quaternion for the world position, to local, and the shift is the one that does the conversion. The to local is once it's on the target side, and I want to bring it back into local quaternion. So this, like I said, all these things are just pre-computed and pre-saved. So this way, when I go through the animation, or when I go through the retargeting, it just looks like this. Super simple. So I go through all the bones in the map. I just multiply the from world, and I put in the local space of the animated one. I do the dot check. Like I said, I don't have to go looking for the dot check. The dot check is already predefined. And then I just do the negation. Then I move the bone from local space. Move the bone to local space for the target bone. Oh, this is the local space transform. Like I said, that's already been pre-computed, so I don't have to worry about it. I don't have to go looking for the parent and then invert it, because that's what I did in the original function. So, like I said, this becomes super dead simple to pre-calculate everything. And since I'm retargeting at runtime, it just makes things more optimized. And the hips, and this is how I retarget the hip position. I'll just look at the pseudocode because it makes more sense. And like I said, up here at the beginning of the function, I actually wrote pseudocode to make the math easier to understand. So shift is the from T-pose, get the bone from world space, rotation inverted, times the to T-pose, bone, world space rotation. Then you got the difference, and the other thing, blah, blah, blah. But the pseudocode for the retargeting, I take the target world space position divided by the the source world space position, that gives me the scale. Then I can take the world space position of the source, the bind pose source, and then the animated source. So the idea is I want the difference between the bind pose and the animated pose. So it's the difference, like how much movement was actually done between the resting state and the animated state. So so if I'm resting at 0 and my animated state is 5, what is the difference? It's 5. So this way I know that, and then I multiply it by its scale. So if I know the scale between the two, like between the target and the target and between the target and the source, that scale can then be applied by the difference of the source's bind and animated pose. So once then I scale it down to whatever my target, like, because Vegeta is smaller, so the position is different. So the height of the Vegeta's hip is different from the source animation, which is like a monster or a girl, whatever it is. And then the final is I take the local space position of the bind pose and add the difference that this calculates, and that moves the position, that moves the hips exactly where it needs to go. So this is how you retarget vector information, and this is how you're going to retarget Quantorian information. So this hopefully makes it a lot easier, I guess. Hopefully it's not too encoded, but you have this, and then you have more comments, which I kind of repeat the same crap over and over again. So like I said, in a lot of my this example, I comment the hell out of it. I repeat myself, and I'm probably repeating myself a lot in this video too. I don't even know how far this video is. It's already 40-something minutes long. And that's it. That's all the code. And we can go to the very, very top. And this is the final steps. I animate. I apply the pose. So this I can visually see the animation. Then I update the world space positioning of the animation of the pose. So pose A has all the local space stuff. So this just generates me all the model world space information, because I need, and like I said, I need the world space version of it. Then I run the retarget. And then when the retarget is done, I just, because it's already saved in the pose, I say apply pose, which then saves everything right back to the actual armature entity bones. And then just run my regular animation system. And that's it. And then that fissions. So if I click save, if I go back here, and ta-da! Perfect. Perfect. The animation is perfect. Vegeta's butt is in good shape, because when there's a singularity, Vegeta's butt breaks. It always does. It does. The knees break, his butt breaks, sometimes his head breaks. I don't know. But like I said, it's perfect. It's beautiful. I love it. It's great. The last bug I had when I was actually doing this, it's very easy to illustrate. If I take away the shoulder, so after a week, I got everything almost perfect. I had it this way, but I know the arms were off. The arms were off. Like the arms are in the actual animation is lower, but this one's kind of like sticking out more. I'm like, man, it's like this is driving me nuts. Then I noticed something very strange, because I kept going back and forth between the animating it and not animating and seeing the two poses, and I noticed that the shoulder bones were pointing down, but when a T pose, they're pointing straight across. Like, wait. I was like, wait a minute. The shoulder bones were actually animating. I didn't realize that the shoulder bones were actually animating. I thought it was just the chest bone was animating, and the shoulder bones just follow along with it. I didn't realize the shoulder bones actually animate in the animation. So these bones are pointing down, but Vegeta's shoulder bones are pointing out. So I was like, you know what? Let me just add. I'm just going to retarget this, because in the original prototype I was retargeting one bone at a time. I'm just target the left bone. Now it's perfect. So that probably killed me a day or two of my 1 or 2 evenings of my time, and it was all because I wasn't retargeting every bone. So if you're doing all this retargeting stuff and the code works beautifully, like if you're using my code, right, and for some reason something's off, everything's animating, everything's kind of good, but certain things are off that like they're just not exactly where they're. Make sure every single bone that's attached to whatever that seems off is being retargeted, because that might be the problem. So if you're doing retargeting, ideally you should retarget every single possible bone that you can. In this one, I'm not retargeting the feet or anything else, but the spine, the legs, the head, just about everything's being retargeted except for the hand and the fingers and the feet, because I don't feel like it. But because everything kind of does work though. And that's it. And I can also show you, because I do have an online demo of it. And if I go to armature, I go to retargeting, and here's another animation. This is the catwalk from Mixamo, and Vegeta sashaying away. So once I was done getting everything to work, I tried another model, make sure it works with another model, and then after I was done, I started trying other animations. So I have a walk animation, a run animation, and I have a sashaying animation. If you go to Patreon, it's free link, I'm not making you pay for it. I will be posting the project files with all 3 animations, so you can just uncomment the code and you can try out all 3 animations, and you'll have all 3 animations to experiment with if you want to prototype. So if you're prototyping, you might want more than 1 animation. So this way you have walk, run, and sashay, because if you can sashay, then the animation system you have is actually working, and you're retargeting, because this is a very funky animation. There's some clipping, but whatever. And that's it, and that's animation retargeting. Ta-da! No springs. We didn't do any springs. So I want to kind of show you what this final milestone. We're going to be really focusing on animation and getting characters to move, and that's why we're doing retargeting, because I want to bring animations in, and I want to use. And it'd be kind of cool if I can create my own little tools that will retarget the animations and then export them in a nicer, cleaner format instead of using GLTF. So this way, it just export it into like a text file that I can put on GitHub and things like that. So that's kind of really one of the main reasons why I did retargeting, because I want to do my own retargeting instead of using a tool that I'm stuck still using GLTF. I kind of want to be able to pull everything out of it. Pull it out and then save it in my own little format. So this way I can have my animations kind of just load in a serialized way. So this way I don't have to parse through code. I don't have to go through binary, because getting the binary, going through the bin file takes a bunch of steps, and you have to calculate things. And then you have to get the skeleton and everything else. If I have all that stuff pre-computed and serialized right back into a text file, I could basically just load everything right back in and just continue. And that's really why I'm doing a lot of this, because I want to be able to build characters that walk and climb and run, and I need animations. The next step really that I need to do is that the next video, maybe, it depends how much time it takes, I'm able to do like a small video about something else, this has been the main goal for the past over a year now, is to build the IK rigs from Ubisoft, where you have the animation retargeting working for different bones. So this one shows you the animation retargeting, and it looks like basically what I have. But the magic of theirs is that they can change the animations on the fly, and it's the same animation, but you kind of just piece things together. But then you have animations work on different bones. Like you have this green guy doing the same animation but different, and then you have the yellow guy who's a strong guy. He's different, and then the female has a little bit of hip twist into it, but the animation is all still there. And again, like he just keeps showing you different versions of the exact same animation being retargeted for all these different armature bones. And some of the most impressive things is then he adds it to this robot monster. So that's a walking animation. And you know what? The way I'm seeing the legs work, I'm having the same issues, and it looks like it's okay because he has the same issues. Also, I'll show you that in a second. I haven't seen this video in a year. I really want to watch this video again because it's been a year. I have much more experience, and I have a lot more working knowledge of how these things work because I've been building them from scratch. So if I watch this again, I might actually get some extra clues that maybe help me get this working better. But what of my understanding from a year ago? Yeah. So if I go to IK and I go to IK retargeting, here we go. I'm actually a little bit further along than this because today I managed to put in hip movement. The hip movement is a little jaggedy, but just like the Ubisoft, I do have, and this is actually being retargeted with inverse kinematics. So that's why you see these new visualizations I kind of built in to kind of visually see some of the IK stuff. But as you can see, there's a walk animation, which is like a 2-bone leg, and I'm doing IK retargeting on Vegeta, which is also another 2-bone leg. So it's no big deal, whatever. I can do retargeting or IK retargeting. I'm getting the same results. But the magic is now I have this robot, which kind of has the legs going back and forth a little bit, but that's okay. But this is a 3-bone animation, and a year ago I built a 3-bone IK solver, and I built 3 other solvers too. I made the leg, I made the 3-bone, I did like a circle arc, and a couple other ones. So this way I can take IK information and then move bones based on the specific solvers. So this way I have one walk animation based on that actually runs on this animal. So it's a human animation applied to an animal type of bone. Just like in the other video where you had that robot that had a completely different type of leg than a human, but it was still doing the human animation. And I'm able to take it a step further with this. I'm actually able to process animation. So you have a walk animation, and you can see at the bottom, I'm processing it and saving all the world space positions, right? So I can do the world. So I save the world positions of everything. So that's the path. That's the actual animated path. So if I use IK, I use the stride test. So now I have a different way to retarget. So it's still IK retargeting, but a different way where I pre-process the animation and just save the actual path. So you might be like, oh, well, why am I going to do the path? Because once I have the data and I'm using IK, I can do some interesting things. Now I can use this thing. Now I change the stride. Now the animation is different. And I'm doing this in real time. So right now I made his stride longer. So he's taking longer steps. And then if I want to, I can then scale it by the Y. So that means he has a bigger loop on the way back. And, if I want to, I can make it really tiny, and then I can make it really close by. And now it's kind of, well, you know what, maybe just scale it up. Too much. And there you go, a little better. But see, as you can see, I pre-processed the animation, and then using IK to retarget the motion, I can then actually save these as animation paths that can be scaled and tweaked and changed. So like I said, now he's kind of walking a little slower. If I change this a little smaller, it's kind of a little tippy toe. But like I said, if I want to, I can. So now, like I said, now I can actually just scale it up a little bit. Just go full, scale the Z a little bit. And then just speed up the animation. Now a walk animation has been in real time converted into almost like a run animation. If I do certain things, I can probably make it work really well. Yeah, there you go. So that's really the direction we're going. It's like like I said, really reaching the near the end of the milestone, because my milestone was if I can build the IK rigs from Ubisoft, then I finally hit the next milestone of Fungi, and it's taken a year to get here, but it's getting here, and we're now going to start doing some really, really fun stuff. So this is just like some of the prototypes I've been building the last a week or two. I think it's been a week or two. Yeah, maybe 2 weeks, I think. Doing retargeting, but using inverse kinematics. I don't think I have anything else cool to show you. So let me just do this. I like the dark theme better. I'm going to do most of my videos from now on using the dark theme because I like to use the colors, and they visually pop better for me. And all this brightness just kills my eyes. So yeah. So that's really that's where we're going to going for the next set of videos, just like springs, where I sat there and just did a bunch of videos about springs. The next set of videos is really going to be focused on animation. Retargeting animation, using IK to tweak and change animation, taking animations and make them dynamic. So this way you can then you can tweak an animation and then save out all the keyframes and then save it. Because maybe at the end of all these videos, I can then start building tools like Mixamo, but a much cooler version of Mixamo, because Mixamo can't allow you to change. Yeah, I think it kind of gives you some animations you can configure a little bit, but yeah, you could start building tools like that. So this way you can take an animation, you customize it, you tweak it. I want to take it a step further, where I can take this the sachet leg motion and then put a different arm and torso motion into it. So this way, ideally, I can say, mix and match animations. I want this type of animation, I want this type, and then combine it all together and then export it as a final animation. So I want to do more than just animation retargeting. I want to do animation mixing and blending and mix and match, and to basically make animation into Lego pieces, essentially. I don't know how well it's going to work, but that's really going to be the goal. So this way, if I have a nice library of animation pieces, I can then make animations for all my characters. And by using all these retargeting bits of code and tools that I'm building for myself, I can very easily, design a character, have all these animations, run a tool, and then have another character have all these animations because they get retargeted. Or I can just retarget them at real time when the game is loading up if I really want to, So yeah, it's a lot of exciting times. This video is already over an hour. I'm tired. And I'm really excited, though. I'm tired, but I'm excited. And hopefully one day I get to do this for reals. Not bad for a guy with no college education, right? And EA. That's what you get for rejecting my resume 3 weeks ago. You're not gonna get any of this from me. Whatever. I don't care. I give up on being a game developer, like a professional game developer. I don't think I want to be a professional game developer. I just want to be a developer. I just want to make cool, amazing stuff. I probably spend if I could, I'd probably spend the rest of my life building one system after another until I have a billion different types of versions and systems for games, and it'll be all out there for people to use. And I don't care. I've been told that this stuff no one's doing this. No one is really doing this. Teaching, releasing a lot of source code, explaining it. So why not? Hopefully people get a good out of it, because maybe, like I said, the more people out there that know it, the more help I can get, because it's really getting hard to do this on my own without any help, without any guidance. But I'm chugging along, excuse me, just chugging. And eventually, if I push it enough, I usually get some results. So here's hoping I get the IK stuff working sooner than later. So we can start doing some more stuff, because I can't wait till I can start retargeting. Once I get the IK system kind of up and running, I'm going to probably take some time off, do some 3D modeling because I wanted to make a 3D character. If I knew a 3D modeler that can help me out, that'd be great. But maybe I want to do it on my own, so this way I can say it's mine and not someone else's. But if I had someone help me, that might make life a lot easier because I have some ideas of what I want to do, and if I can just get a good base model set up, then I wouldn't mind modeling the rest of the pieces on my own. So if there's a model out there that wants to help, maybe I'll take that offer. If not, I'm probably just gonna do it on my own, just like everything else, because I'm a whack job like that. So let me end this really long video. And if you please like and subscribe. Eventually I'll be able to make some pennies on these videos, but whatever. If you like the code, if it's really helping you out, please donate $1 to my Patreon. Surface Pro 7 was announced today, and I kind of want to get one. Maybe, I don't know. I have a Surface Pro 3, and I can't put it in sleep mode anymore, else I get like the black screen of death, and it takes like 3 hours to reset it because I have to like tape a stick to the power button, and then it has to do it's stuck in a boot loop. If I put it in hibernate and then try to boot it up, it goes into a boot loop, and it's stuck there unless I like literally have to put rubber bands in the stick on the power button and just wait there for like an hour or two, and then it boots up finally, and then I can just use my tablet again. Why would I want a Pro 7 if my Pro 3? Because I just like something light, and it's a great machine. It's just probably old and it's got beaten up, and I abuse it the hell out of it to make all these funky animation stuff. I just like to have a nice light portable device to do development so I can go anywhere. Because it's kind of like this, my desktop, it's kind of hard to sit in my desk all the time to work. I kind of sit in the living room, or you'd be surprised, I actually sit in the car and program a lot. Like at nights, I usually wait for my family to finish martial arts, and I'm in the car typing away. So having a nice light laptop that's easy to work, that's powerful enough to do the work, and it's great. So if you want to help me get a Surface Pro 7, just $1, and I need $1,300. But no big deal. I kind of I'm gonna save up Christmas and my birthday's in January, so I get a lot of gift cards. So I'm just gonna save that, and plus whatever I get from Patreon, and pull it all together, and then maybe get something. If not the Surface Pro, I'll probably get something else, whatever is good for me to develop on mobilely. So yeah, I wasted enough time promoting, trying to get some money for my tech, and I still want to get a Windows mixed reality headset, the Samsung Odyssey Plus, because I want to do XR, WebXR. I want to do VR stuff again. So that's kind of iffy about Surface Pro, because I don't know if it has enough power. Mine doesn't have enough power to any VR right now, so I don't know if the new one 7 has any power at all. If it doesn't, then I just have to find a gaming laptop. But the gaming laptops are heavy and big and clunky, and not portable. So that's kind of like the thing. I need a portable thing. Else, I'll just have to use my desktop for VR. But it's hard to it's hard to sit at my desk at night when I want to kind of spend time with my family, watch a movie. I actually code and watch movies at the same time. This stuff has got to get built somehow, right? All right, that's it. I'm done promoting and bitching and whatnot. I got flagged again for cursing. See you guys in the next video. It might take a while because IK retargeting is very difficult. It's a little glitchy. And again, I have no help and I have no clue what I'm doing. Yet somehow I got Vegeta the Sachet, so I'm definitely over 9,000. Yep, I'm over 9,000. I got Vegeta the Sachet, and there's nothing you can say or do about it. See you in the next video.